That will be right in a few weeks. I always know that I never change. I just really hear this. All right, it's 5:30. Let's go and get started. Good afternoon, everyone. My name is Professor Justin Tran, and this is EGME 410, Finite Element Analysis. Hopefully, you guys are all in the right place, because there's a lot of you. But if you're not, I'll close my eyes. You can leave the classroom. No thing. Okay. Just kidding. All right, and so today is the first lecture. So very exciting day. We're here in the fall semester with 410. And so the plan for today is I'm just going to introduce the course today. So we're not going to do anything, no notes or anything like that. And so just going to be kind of a chill day. So we're going to talk about what the course is, what you can expect from the course. We're going to talk about the syllabus, the course website. So kind of all the administrative introductory stuff we're going to get out of the way today. And then on Thursday, we're going to do ANSYS. And so, I know this class, there's a lot of expectations that come with this class. The question I get almost always is, when are we going to do the ANSYS? When are we going to do the ANSYS? We're not going to do ANSYS today. We're going to do ANSYS on Thursday. So Thursday is literally the earliest we can do ANSYS. So we're not going to do it today. We'll do it Thursday. Okay. And so today, I just have the slides, so I don't have any notes for you guys to take. So you guys can just kind of sit and listen. Okay. So first, let me get this out of the way first. And so I know there's quite a few of you on the wait list. Honestly, it was a little bit surprising to me how big they made the wait list and how many people were on the wait list. And so I didn't expect to have this many students. And traditionally, what I do for this class, just because I know, there's a lot of you want to learn ANSYS, and a lot of you, want to apply it to all your different projects. And so I always try to be as accommodating as I can. My original plan for this class was to have around 50 students. Right now, there's more of that on the wait list. If you add the number of people in the class and the wait list combined, it's more than 50. So I don't know if I'm going to add absolutely everybody, but I'm going to try my best. And the other thing we're kind of fighting with at this point is the capacity of the room itself too. So, but I would say just kind of, if you're on the wait list, stick on the wait list until the end of the week. Hopefully, some people move around and, we can be at that 50 number, but don't give up hope. So stay until the end of the week and then you'll get a clear answer. Okay. All right. So who am I? So I am Professor Justin Tran. So I know quite a few of you have had me before, so you're well acquainted with me. And so first thing you should know about me is that, you can call me whatever you want. So I think most people call me Professor Tran, Dr. Tran, Dr. Justin, Professor Justin, all of it is fine for me. Okay. One thing that I do say every semester is that, I grew up, playing like League of Legends and Team Fortress Tactics, or Team Fortress 2, excuse me. And so I'm no stranger to people on the internet calling me all kinds of things like dick face and stuff like that, right? All because I made a misplay, whatever, And so, so you can call me whatever you want. One person actually did call me, they did email me and say, hey, dick face. So it's been done. So, you would no longer be the first, but you can still do that. All right, so call me whatever is comfortable for you. If it's comfortable for you, it's comfortable for me. Okay. My office. And so, so I actually am moving offices. So my old office is here in CS. And so when I made these slides a month ago, trying to be very proactive, very, ahead of schedule, I thought I would be in my new office, but of course I'm not, okay? And so my new office will eventually be in engineering, but I'm not there right now. And so right now I am in CS 5. CS 526. Okay. Good. This is the third time I've written it with the mouse, and I've gotten better each time. So it looks less serial killer by the third time. Okay. So that's on the 5th floor of this building. And so if you come to my office, don't go to engineering, go to CS. So I'll be there. And then once I move offices, which I think will probably be in a month or two, I'll let everyone know. So I'll send an announcement on Canvas just so you'll know that I officially. Okay. All right, there's my email address. So my email address is justran@fullerton.edu. So that's probably going to be the main way that probably most of you will communicate with me. And so you can send me an email. I'll talk about my email policies later, but generally I tend to be pretty good. And so I answer my emails about usually within a day, 24 hours, if not 48 hours if I'm really slow. All right, so where am I from? So I grew up around here, and so I'm very familiar with Cal State Fullerton. In fact, quite a lot of my friends from high school actually came here, which is cool. Okay. So if you don't know where Cypress is about 10 miles west here down the 91. Okay. All of my college has been in California, and so all in mechanical engineering, and so I've gone basically all up and down California. And my research interests involve using engineering tools, specifically finite elements, for biomedical applications. So I use it to study heart and blood disease. I've done a little bit of biomechanics too, and so this class is definitely something I'm very familiar with. Okay, learning objectives. And so if you've had me before, you should be very familiar with these. And so what I like to do at the beginning of every class today is to give you guys a list of learning objectives. So you can think of these learning objectives as kind of almost like an outline for what we're going to cover for the day. Okay. And so what I always tell people is that at the beginning of class, I always recommend that you write down the learning objectives. Okay? It's a good way to organize your notes. It's a good way to kind of, prime yourself and to kind of prime your expectations in terms of what we're going to cover that day. Okay? But I also think it's a great way to kind of go back into your notes to kind of review them to make sure that you understand everything that you need. Okay? Because if you read these learning objectives, you'll see that I write them in a very specific way. And so I write them using a verb as the first word. Okay? And so I want these to be kind of actions that you can do. So for example, the first learning objective that I have here is to describe the use and utility of finite element analysis in engineering. Okay? And so by the end of today, what you should be able to do, and so if I see you walking out and I stop you and say, hey, describe to me the use and utility of finite elements, you should be able to tell me, without me being disappointed. Okay. And so if you're able to do that, then that's great. That's one of the main points of the lecture. If you're looking through your notes again and you think like, maybe I can't really do that just yet, that's usually a good indication that you should go back to your notes, you should study again, maybe watch the lecture recorded, just to make sure that you fully grasp it. Okay. And so I post these at the beginning of class every day. I encourage you to write them down. You don't have to write them down for today, but they're just kind of examples for how the class is going to be. Okay, so let's get into the course content. So what is FEA, right? So probably at this point, I think a lot of you are seniors, or a lot of you are graduate students, so you've probably heard the term FEA, finite element analysis, FEM, finite element method. So it's a term that's thrown around a lot, but what is it exactly, and why is it important? Okay? And so finite element analysis, the way I describe it is that it's a numerical technique for solving differential equations on arbitrary geometry. Okay. That's probably not the definition you were expecting, because I think a lot of people associate FEA with like ANSYS, right? But if you look at finite element kind of as a raw method on its own, all it's really doing is solving differential equations. Okay? And the way it does this is that it uses kind of the computational power of computers to perform all of the arithmetic and algebra that's needed to do these calculations. Okay? And it does it at such high speeds that you can use them on very complicated geometries with complicated boundary conditions and loadings and all that stuff. Okay. Right. And so why is it important? And so, because finite element analysis is kind of designed as a computational technique, it's really become at this point, really fully integrated into what we understand as the engineering design process, okay, and analysis. Right? And so when you have practical engineering systems, oftentimes you're going to have geometries, you're going to have situations that are really complicated, right? And so these are situations that you can't really analyze by hand, right? Unless you make very, very big simplifications. Right? And so if you want to analyze things, that are true to their geometry, true to the conditions, you need some kind of computational technique to kind of help you. And FEA is kind of the method of choice for a lot of different things. Okay, so let's give some definitions. Okay, and so I'm going to talk about analysis a lot because FEA at the end of the day is a type of analysis. And so when you look at the different types of analyses that are done in engineering, there are three different kinds, or at least I categorize them in three different kinds. Number one is analytical, right? And so these are what I kind of term to be kind of pen and paper calculations. And so if you look at all your previous classes in theory, so you think of like 331 solid mechanics, so 407 heat transfer, 333 fluid mechanics, right? A lot of those classes involve you solving equations by hand, right? Often painfully and sometimes involving crying, but you solve it by hand. And so those are what I call analytical methods. And so the good things about analytical methods is that they're usually fairly fast and they're inexpensive, right? So all you need is a pencil and paper and probably just a very sad engineering student. But the problem with this is that you can only use them on very simple problems. Right? So as soon as you throw any kind of complexity, even when you go from 1D to 2D, it kind of becomes impossible to use analytical methods. Okay. But it's important to note that that is a valid type of analysis. All right, number two is experimental. So experimental refers to going out and trying it in the real world, either doing a lab test or doing a field test or something. Okay, and so number two is kind of the best way. What I always say is the best way to get data. Okay, and so ultimately when you design engineering systems, they're designed to work in the real world, right? And so we're not playing Minecraft. We're actually designing things in the real world. So to really find out if your design is going to work in the real world is to test it. And so that's what experimental is. And so, to go out there, get concrete evidence, get concrete observations to see, if your car is going to, withstand a crash. And so experimental, I would say it gives you the best data, but it's also the most expensive. Right? And so if you're doing, for instance, crash testing, if you have to destroy, a very nice car just to test your design, your manager's not going to like that very much. You buy 10 cars just to test your design. And so the third type of analysis is computation. So that's what we're going to be focusing on in this class. Okay? And so in spirit, it's very similar to analytical in that, in order to get the data, in order to get the results, ultimately we're going to be solving equations. Right? It's just that the way we're solving the equations is going to be different. Instead of doing it by pencil and paper, we're instead going to be using computers to solve it for us. Okay? And this kind of gives you the best of both worlds, where using a computational method, it's relatively fast and inexpensive, right? You don't have to destroy anything or build any physical prototype. You can just do it on your computer. But because the computer is able to do a lot of calculations very quickly, you can handle a very lot of complicated situations, and you can get some very detailed data from it. Okay. The problem is with computational is that it can be very tricky to set up sometimes. And it can be very easy, in fact, to set it up incorrectly, which we'll go over a lot in this class. And kind of the bigger danger is that people kind of take computational results too seriously. So they'll run something in ANSYS, they'll think it looks great, and then they'll build something and they'll realize their computations were wrong. We'll go over what we're going to go over a lot in this class is to not only how to set up FEA properly, but how to spot bad FEA and kind of know how things are going to be. All those things. All right, any questions on this so far? Okay, so let's do an example to kind of show you kind of the limitations of all the different methods, right? And so let's say that we're analyzing a beam, right? So here we have a simple beam, a pin support on one end and a roller support on the other, and we have a distributed loading on top, right? So this is probably a problem that you've seen in 331 in your previous classes, right? So this problem, I think, is simple enough that you can solve it by hand, because there's a beam equation that you can solve. and this geometry is simple enough, the loading is simple enough that you can solve. But in terms of practical usefulness, you're almost never designing a simple beam, right? By itself. And so kind of a more realistic situation is something like this, right? So let's say that you're in charge of designing an entire building, which is made up of hundreds of beams, right? And you want to see that when you want to see it is, when you load these beams, when you put people in the building, when you put furniture, equipment in the building, are the beams going to survive, or is the building just going to totally collapse on itself, right? And so this kind of situation, is way too complicated to solve by hand. And so you need to use FEA to solve this system. Okay? And so if you were to run an FEA simulation, you would probably get a figure something like this, where the colors kind of represent something like, maybe the amount of structural stress that the part is under. And so the red areas would indicate, those areas are probably more likely to fail than the blue areas. Okay. So FEA, for this class, we're going to be focusing mostly on structural engineering. And so, we're going to be doing a lot of examples just like the previous one. But you can also use FEA to solve different types of problems as well. So I would say the second most common use of FEA is in thermal engineering, heat transfer. Okay. And so here what I have is a very simple heat transfer problem. So we have a rectangular wall and we have a gradient of temperature. So we have a certain temperature on one side, T1, and a certain temperature on the other side, T2, okay? And so with a very simple case like this, you're able to solve this by hand using the heat equation to find out, how the temperature varies. Okay? But if you were to have a more complicated situation, so let's say that you have, in this case, we have a turbine blade, okay? And so let's say that it's part of an aircraft engine or something like that, where you have hot gas that's passing through, as a function of time, and the turbine itself is spinning, right? And you want to find out whether your turbine is going to melt or not, right? And so in this case, because you have fairly complicated geometry, very complicated boundary conditions, this would be basically impossible to solve that. You wouldn't be able to solve this using pencil and paper. And so you would have to use FEA to solve this type of problem. All right, and so the final example that I'll give is in fluid mechanics. And so I would say this is a little bit less common. And so if you're using fluids, if you're going to do CFD, typically you use a different method called finite volumes. But technically you can use FEA for fluids as well. It's just you have to kind of formulate it a little bit differently. And so here again, kind of the theme that you're seeing here is that you can have very simple problems. So this is something very simple that you probably solved in your fluid mechanics class, and so you can solve for the velocity distribution. If you have something with a more complicated geometry, like something like this, where you have multiple cylinders with varying sizes and different angles, this again would be impossible to solve by hand. You would have to solve this using computers. This particular image is actually from one of my colleagues from when I was in grad school, and this is actually an image from inside a person's body. And so this is kind of an experimental surgical procedure where they connected two blood vessels. And so, normally these two blood vessels here are not connected, but he's testing a procedure where if you do connect it, maybe it could help certain patients with certain heart conditions. He ran simulations on it, and it's kind of still developing. All right, so hopefully, the theme that you'll see from all these examples is that, yes, it is important to know how to do the analytical calculations, the pencil and paper, because that's where you really understand the concepts of the theory. But when you actually go to actually apply that to complicated practical situations, a lot of the time you're going to need to use computers to help you out, and FEA is kind of the method that's used. Okay, any questions on this so far? Okay. All right, so for the next part, I want to turn it over to you guys, and this is honestly the part of the semester that's most exciting. I'm always really hyped to teach this class because I know a lot of you are coming into FEA with kind of an application already in mind. So either you have your senior design project already, or you have maybe something you're working on at work, or maybe just something you're interested in personally. And so I want to hear from you guys. And so what are you either what are you working on for your senior design that you want to apply FEA to? Something you're working on at work, or just anything. So what are you guys looking forward to applying FEA?
Okay.
Rocket, yeah, Titan Rocket. Yeah, I think almost every year there's always at least one or two projects at the end that apply FEA to Titan Rocket. So yeah, great application. I think last year they actually did a thermal, they did both a structural and a thermal analysis, which was good. Anything else? MJ, so medical devices, yeah, great ones. That's definitely something in my wheelhouse. So it's something I've done before. So yeah, medical devices as well, because yeah, there's a lot of testing that goes into medical devices, and medical devices have the additional complexity where it's even more expensive to test them, because if you test a medical device on someone and it doesn't work and the person dies, that's even worse than wasting a lot of money and you're responsible for killing someone, which is really bad. And so the FEA is used a lot in the
stresses on.
Absolutely, yeah. So automotive, and so I know I get quite a few projects from Baja and Formula every year, and so yeah, that's definitely really good too, especially for the suspension system. That's where a lot of the stress in the is maintained. Anything else? Yeah. For a second.
Marine applications.
Marine applications, yeah, that's a great one. Yeah, that's definitely a good area, because just like a lot of other fields, it's very expensive to build prototypes in that field. And generally, you don't want to build too many of them, so FEA plays a really important role. Anybody else? Anyone on Zoom too? Awesome. Yeah. So I'm looking for. I always love this. I'm always looking forward to it. So just to give you guys a sneak peek. And so the final project for this class, we're gonna spend most of this semester, learning about ANSYS, learning about the theory. And for the final project, I'm gonna let you guys apply ANSYS to an application of whatever you choose. Excuse me. And so for a lot of you, I know that ends up being your senior design project. That ends up being, one of the legacy projects. And so, I always look forward to seeing, how you guys apply it. And it's kind of my way of kind of learning what the senior design projects are without having to talk to the senior design faculty. Less social interaction. Okay, all right, so let's go ahead and move on. Okay, so what is the finite element process? And so, since on Thursday we're going to jump right into ANSYS. It's going to be a hectic day. Honestly, it's probably going to be the most hectic day of the semester. Before we go to Thursday, I do want to kind of outline the typical steps of an FEA so that you're kind of ready for Thursday. I'm going to be flying all over the place on Thursday, honestly, helping people with certain things. And so, I at least want you guys to know kind of the general process that we're going to follow, just so that Thursday will make a little bit of sense. Okay? Because I think, what ends up happening Thursday, even with this, is that, you're going to kind of follow the steps in the activity, but, you may not have the context of kind of why we're doing each of the steps. So I want to go over that context today, and so, just so that you can kind of understand. Okay, so the first step in FEA is always to define the geometry, okay? And so for most cases, this means to either create a CAD model or to import a CAD model or to get a CAD model from someone. Okay? And so I think at this point, most people have taken the SolidWorks class, and so you're familiar with the concept of CAD and constructing a geometry. So FEA always occurs after that. And so, you can almost think of this class as almost like the sequel to 322. Okay? And so before you can even start doing FEA, you have to have a geometry. That's always the starting point. Because what the geometry defines, it defines kind of the bounds of your simulations. Define the subject and kind of where you can apply the boundaries. Okay? And so, for most practical cases, you're going to create this geometry in a separate software. So ANSYS itself, it has its own CAD software. It's okay, it's not bad, but usually, if you're using something like SolidWorks or CATIA, those are usually have a lot more features. It's generally easier to make the CAD there. So for most people, you're going to create the CAD and say SolidWorks, and then you're going to import that into ANSYS and then kind of work on it. Okay, second step, you're going to specify the material properties. So, getting the geometry is the first step. From there you have to define, what material is your part made out of. Okay, And so, I think this is a step that you probably have done in part of your SolidWorks courses, but probably mostly is just for the visual effect, right? So that you have kind of metal parts, they look metal, they look shiny, and the wooden parts, look wooden and not shiny, right? But for FEA, it plays a more important role because, all the different materials, they have different strengths, right? And so we expect, something like steel to behave a lot different than rubber, right? So if you have a car made of steel, that's going to give you a lot more confidence than driving around a rubber car because, the rubber car is just going to crumble, right? It may not even support the weight, okay? And so a very important part of FEA is to, once you have your geometry, define what material it's made out of, so that it can behave appropriately, right? But because the next step, what we're going to do is we're going to apply boundary conditions. So we're going to apply loads and things, right? And so when you apply 100 pounds onto a steel frame, that's going to behave a lot differently than applying 100 pounds onto like a rubber frame. Okay. And so, applying material properties is very important. And actually, surprisingly, a step that a lot of people forget, especially throughout this semester. So, definitely don't forget this. Okay. And so probably some terms you're familiar with in terms of material properties are things like the Young's modulus, or the structural modulus, things like density, Poisson ratio. Okay. All of these are important in terms of how the material behaves. And so you want to make sure that you have the right numbers for all these things. Okay. So the next step is to discretize. And so this is probably the coolest step and probably the step that most people see when they look at FEA. Okay. And so by discretization, what I mean is to take your geometry and kind of break it up into much simpler shapes. Okay. Because the way FEA works is that, ultimately you're going to be solving, the equations of solid mechanics on your part, but you can't do that on a very complicated geometry, at least not directly. And so the way FEA works is that it takes your geometry and it breaks it up into all these little simpler shapes. And so you can almost think of it like Legos. So if you were to look at a geometry, and if you were to imagine, if I were to make this out of Legos, what would it look like? That's kind of what discretization means. Okay. And so if you look at all these different shapes, you'll see that, they're all different sizes, but they're all the same. They all have the same number of sides. They all have the same number of edges. Okay. And this is really important because, you need to do this in order to solve FEA. Okay. And so the step this step is often called meshing. And so this particular thing is on the right here is what we call a mesh. Okay. And so when you say that, I want to generate a mesh, it's to basically generate a kind of a discretization or kind of a breaking apart of your geometry. Okay. And each individual shape here is known as an element, hence the name finite element analysis. Okay. All right. And so what we'll discuss, throughout the class is that, the meshing is probably the most unique part, and probably the part that the step in the process that has the biggest effect on your results. So, we'll talk about this class, how to mesh things properly. To give you the best results. Okay. All right, so the next step is to apply the boundary conditions. And so boundary conditions, these are all the loads and constraints on your part. Okay. And so, oftentimes when you perform FEA, you want to know how the part is going to perform in practice, right? And so when you apply forces, when you apply moments, when you apply torques, okay, when you apply fixes and things like that, okay. And this is the step where you apply all of them. And so we kind of summarize all those steps in something called boundary conditions. Okay. All right, and so boundary conditions, we'll go over that. We'll go over that again Thursday. But think of it as kind of like the loads and constraints. Okay. And to apply the boundary conditions, oftentimes you kind of have to imagine kind of your part in isolation. Which can be kind of difficult to do because oftentimes you're only doing an FEA of a certain part of your structure. And so it's probably connected to other parts, but you kind of have to imagine, if I were to isolate that part, what are the forces that are going to be applied? Okay. And so we're not going to really think about this too much on the first activity, but the second activity, this kind of become more. So this next process here, this next step is called assembly. And so this is the part actually, you don't really have to worry about this part too much because it's handled mostly by the computer. But once you've done the mesh, once you've done the material properties and the boundary conditions, what the computer does underneath the hood is that it creates kind of a very, very large system of linear equations, and it assembles it into a big matrix. Okay. So we'll talk about the theory of this probably in the second half of the course. But you don't have to worry about too much. When the software is thinking, when it's computing stuff, this is kind of what it's doing. The next step is to solve, and so for you, for the user, it's a very easy step. You just click a button and you solve it. But under the computer, the computer is actually fighting for its life, while you're just kind of sitting back and chilling. So, solving these systems is very difficult for the computer. You just don't see it because you're a human, right? But in reality, there's a lot of computations that are done underneath the hood. You just don't really see it. All right, and then the last step is just to admire your results. Okay, and so I call this step post-processing. And so by this point, you'll be able to get things like the deformation, things like the stress. Okay, and the way you display the results is something like this. And so you'll see kind of a color contour plot where the different colors indicate different magnitudes. Okay, and so usually red is used to indicate stuff that's high. And so when we look at things like stress distribution, red usually indicates where stresses are very high. That's where the part is likely to fail. Okay? And blue is usually used for low magnitudes. Okay? And once you kind of are in ANSYS, if you kind of visualize this, it becomes easier to. But this is kind of the last. All right. Any questions on this so far? Okay. Okay. And so we're gonna learn a lot about ANSYS, and I think that's probably the most exciting part of the class. But we are going to learn a lot of background knowledge as well. And so a question I get all the time is that why do we bother learning the background? I just want to learn ANSYS. The background knowledge is useless, right? And so I know that's kind of the general feeling, but by taking this class, not only are you going to be expected to use ANSYS well, you need to kind of understand all the steps in the process as well. Okay. Because at the end of the day, FEA is nothing more than a tool. Okay. And so you can think of it as kind of no better than kind of a hammer or a saw, or a lathe or something like that. Right. It's just a tool for you to do engineering analysis. Okay? And even though tools can help you do amazing things, they can also be misused a lot as well. Okay. And so just like any tools, it has its limitations, it has its best practices that need to be properly understood before you can use it effectively. Okay. And that's why we do the background knowledge, so that you can understand what these limitations are, so that you don't use it incorrectly. Because I think the temptation that when you use FEA is that you think that it's going to work all the time. It's literally your engineering Bible. You just put it in the computer and it tells you what to do, right? That's what people think FEA is, but it's not. It's not going to work all the time, right? And so you need to kind of understand kind of the situations where FEA is going to work really well and situations where it's not going to work really well. And you also need to understand that if you run an FEA, sometimes it gives you bullshit results. And you need to be able to recognize when it's giving you this bullshit results. Right? There's a saying that we have in FEA where we say garbage in, garbage out. And so if you set up the problem incorrectly, or you don't apply the boundary conditions correctly, you have a bad mesh, or you apply the wrong material properties, that's essentially feeding garbage into, right? And if you feed garbage into the computer, the computer is not going to fix your mistakes. It's just going to do basically what you tell it to do. And so it's going to give you results that are basic garbage as well. Okay. And so you need to be able to recognize those situations and know, when the results can be reliable. And at the end of the day, when you exit this class, I want you guys to be able to say that you're experts in FEA, right? I want you to go into your job or whatever, to say that you mastered FEA. And so as kind of an expert in this field, you kind of have the responsibility to not only know how to use the tool, but to know its limitations as well. All right, let me give you an example. So, let me give you the example of a vet. Okay. And so when your pet is sick and you take it to the vet, right, you expect the vet to be able to do what I call kind of procedural skills. And so you expect them to be able to give shots to your animal. You expect them to be able to take a blood sample and perform an eye and ear checks, right? So that's a given. But what we also expect from our vet is they need to know conceptual knowledge as well, right? So they need to know why they're giving your animal a shot, right? They're just not just shooting random stuff into your pet. They need to know why an animal is sick. They need to know, what to do when an animal is sick, and they need to be able to interpret animal behavior as well, right? So they're not just doing the stuff, they're also kind of understanding and processing and analyzing the material as well, right? And so it's the same with FEA, right? Obviously, the context is very different, but when you're an expert in the field, you need to know, the conceptual knowledge. Okay. And so I think this is the last point, second to last point. And so, you may ask, maybe none of you are asking this, but, maybe some of you may be wondering, why do we use ANSYS, right? And so ANSYS, even though it is very common, it is not the only FEA software out there. And so there's another one called Abacus, which is very common, and there's other commercial softwares as well, right? So I chose ANSYS for this class, mostly because it's one of the most popular, and so it's one of the most widely used in a lot of companies. Okay, and so knowing ANSYS is a marketable skill. You can put it on your resume, and that is generally a good thing. Companies will like that. FEA is kind of like coding, where once you learn one software, once you learn one language, it becomes a lot easier to learn others as well. And so I focus on ANSYS just so that you can kind of get comfortable in one. But then you can apply a lot of that same stuff elsewhere as well. Okay, but perhaps the most important reason is I'm cheap and I don't want to buy another software for you, and so ANSYS is free, and so which is always a good thing. And so ANSYS has a free student version that's available for everyone to download. There's a version of ANSYS on all these computers, but you can also download it on your personal computers as well. Okay, which is brilliant, by the way, brilliant marketing to give these free for students, and so. You have all these students that are graduating and they know ANSYS, and so it makes the companies buy ANSYS. Brilliant marketing, but also very useful educational tool. All right. And so finally, one of the last things we're gonna learn in this class is how to verify and interpret the results. We kind of touched on this a little bit before, but FEA is not perfect, right? Sometimes it's going to give you the wrong results. Okay? And so it's important to know, how to check those results. To make sure that they're reliable. Okay. And oftentimes, FEA is not the end goal either. Right? And so oftentimes you're going to take FEA and you're going to do some additional analysis on that as well. And so you're going to do things like stress analysis. Maybe you're going to compute things like volumetric flow rate or heat flux. And so, knowing how to take FEA results and do more with it, do additional analysis is also important. And we're going to go over that as all right, any questions on the course introduction before we jump into the syllabus? Sound good? Everyone's hyped for ANSYS on Thursday? Good. Like that. More you guys are more hyped than last year's class. Okay, let's talk about the syllabus, right? So maybe not so exciting stuff, but we have to go over it. Okay. All right, office hours. And so these are my office hours for this semester. And so again, I'm not here right now. I'm in CS 526. Okay. A little more serial killery, but that's okay. The last time I'm writing it today. Okay. So these are my times. And so Tuesday, they're gonna be Tuesday morning. So Tuesday from 9 to 10. Those are gonna be virtual only. Those are the only office hours that are virtual. Just because it's in the morning and parking here is awful. And so I'll be at home. And so unless you can find the address for my house, then those office hours are virtual. And if you do, then I'll probably have to move, but that's not a good thing. All right, and then but the other office hours will be in person and virtual. So I have office hours on Wednesday evenings, and so between 5:30 and 6:30 on Wednesdays. So that would be in person, but I'll also offer the Zoom option as well. So if you can't attend in person, you can attend on Zoom. And I also have them on Thursday afternoon. So from Thursdays from 1 to 2. And that's again in person and virtual. Okay. All right, so what are office hours for? So office hours are mostly for clarifying course concepts. And so if you're confused about anything that's gone over in class, maybe you kind of missed out on a part of an activity and you're not sure how to do a certain thing. So that's a great time to ask questions for those. Okay. Or if you want to just stop by and say hi, then that's fine too. And so especially in the first week, office hours are usually pretty empty. So if you stop by, maybe you just happen for some weird reason you're on the 5th floor of this building, who knows why. But if you're up there and you want to stop by and say hi, then it'll brighten my day. Okay. And so again, I also offer the office hours on Zoom. So if you can't make it in person, there's links on the course website, which I'll show you. All right, so course level learning objectives. And so these are the learning objectives for the entire course. And so by the end of the course, I hope you'll be able to do all these 4 things. Okay. So number 1 is to describe how finite elements can be used in practical engineering situations. Number 2 is to formulate heat transfer and solid mechanics problems into the FEA framework and solve for their solutions. Okay. Number 3 is to analyze complex engineering problems using commercial finite element software, specifically ANSYS. And number 4, to assess the accuracy and reliability of FEA solutions and troubleshoot any problems that arise throughout the process. Okay. So by the end of this course, you should be able to do all those. All right, homeworks and exams. And so there is 7 homework assignments, and 6 of those homework assignments are going to be ANSYS activities. Okay, so there's going to be 6 ANSYS projects, mini projects, and 1 kind of hand calculation assignment when we go over the theory. 1 midterm exam, 1 midterm project, and 1 final project. Okay. All right. So the homeworks. So since this class is an elective class, and judging by your enthusiasm, most of you actually want to be here. And so in those cases, I don't grade the homeworks for correction. So I just grade the homeworks for completion for this class. But with that said, I know sometimes, the semester can get busy. And so, I do drop the lowest homework. And so if you miss the deadline for 1 or you don't turn it in, don't worry about it. It's going to be dropped automatically from your grade. Okay. But with that said, I do want you to do all of the projects, all the homework assignments. Okay. Because, they all teach you, each of them teaches you an important skill in ANSYS. And the 1 hand calculation problem is you need that for the exam. So, they're all. The midterm exam, there's only 1, and so it's not going to be cumulative. And I think more importantly, the midterm is just going to test you on the background information, on the theory and the calculation. So there's going to be no ANSYS on the midterm exam, but there will be ANSYS on the midterm project and the final. And these are the dates that I have planned for all the due dates. So the midterm project is going to be due on Friday, October 20th. The midterm exam is going to be due in class on Thursday, November 2nd. And the final project, and so your only deliverable for the final project is the final report. It's going to be due on Monday, December 18th, which is the Monday after final.
So the final report is in place of the school final?
Yes, yeah. So there's no final exam in this class. It's just the final project. So the only thing you turn in is just the final report, and also your ANSYS file says this one. Yeah. One thing I'll note is that for the midterm exam, that is only going to be in person. And so there is no plans to offer that exam virtually, and so you will need to come in person for that exam. Okay. All right, course grades, and so this is how the grades are going to break down. And so the homeworks will be worth 10% of the points. The midterm project will be worth 20%. The midterm exam will be worth 30% of your grade, and the final project will be worth 40%. So very nice. 10, 20, 30, 40. Okay. And then based on your scores for those assignments, you'll be assigned a letter grade based on the breakdown, which I think is a pretty standard. Okay. And so, one note that I'll make is that, at the end of the course, if the class average is kind of low, and so for this class, I like to have a class average of around 80%. And so if the class average is below 80%, then what I'll do is I'll add points to everyone's grades until it's 80%. But usually for this class, it's not an issue. Usually my class averages for FEA is usually around 82, 83%, just because everyone generally does a very nice job on their final project. And so I'm not concerned about it in this class, but in case something does happen, then there's that kind of contingency. All right, textbook. So the course textbook is not required. And so one thing, so I think it's been about 10 years, I think, since I graduated from college. And yet to this day, I have this kind of burning, passionate resentment for the textbook industry, or how much money I've wasted on textbook stuff. So that resentment has kind of like defined who I am as a person to this point. And it's one that I kind of carry forward to the rest of it. So if I can avoid giving the textbook industry any more money, then I will take that opportunity. And so I never require textbooks for my classes. But if you are interested in picking up the textbooks for this class, these are the two that I use for reference. And so the first textbook, the Logan textbook, that's going to be for all the background information for all the theory. And then for the second textbook, the Lee textbook, that's going to be for all the ANSYS stuff. Okay. I think the Lee textbook, I think he comes out with a new one each year. And so this one might be a little bit out of date, but it might be easier to find a cheaper version of the second textbook. Question again.
You get the second one. And
okay, yeah, and yeah, Amazon is probably a good option. But with that said, for all of the homework assignments, I'm going to be posting the full statement, so you don't have to look up problems in the textbook. You don't have to, do any readings in the textbook, or like post all my lecture notes. And so, you don't need the books, but if you want them for references, these are some good ones. The second one in particular, we're not going to cover everything in the second textbook. And so if you're interested in some of the more advanced features and answers, then the second textbook would be good. Okay. And as always, I always recommend people, find a cheaper version, find it secondhand if you can, or use Google, and Google is usually a good resource for finding. Okay, course website. And so the course website is a great resource, and so we'll be going over the course website after this. Okay. But basically, any content that I create for the class, I'm going to be posting on Canvas. Okay? And so that includes lecture notes, lecture slides, homework assignments, ANSYS tutorials, handouts. What else? Some homework solutions, study guides. Anything. I don't hide anything from this. Anything that I make from the class, I put it on the website. Okay. I also make announcements through the website as well. Okay, so announcements will be made on Canvas. And I also have a Discord server for the class as well. Okay? So the Discord server is optional, and so I think some people have joined it already. But this is something that I started over the pandemic, and so it was kind of like a substitute for kind of the physical classroom. And so it's kind of a place for you to kind of interact with your classmates, ask questions, get help and answers, form study groups, things like that. Okay. And really, I created the Discord to be kind of a space for you guys. So, I'm usually not that active on the Discord server. And so, you can post, memes of, you can post memes of me on the Discord server, people have done that in the past. And, it's really just for you guys, right? But, if you want me to answer a question, you can always tag me, and then I will come into the server and answer the question. All right, so this last note is important. And so, I'm on Discord a lot just because I use it for talking with my friends as well. And so, if you really need my immediate response on something, you can message me on Discord. But I would ask that you only save this for emergencies, because what's happened in the past, more so over the pandemic than anything, is that students have kind of abused this and kind of messaged me at kind of all hours of the day and expected me to respond at like 3:30 in the morning. And so it kind of had a bad effect on my mental health, and so I kind of had to put a stop to it. So I'm not saying that you can message me on Discord directly, but try to only save it for cases where you need my immediate attention. Okay? Otherwise, I prefer email, and so email is probably the best way to contact me. Or you can message me on Canvas. I think there's a messaging system there. Or you can tag me in the Discord server. So all of those are preferred. But if you absolutely need my attention, immediate attention on something, then you can direct message me on Discord. Okay, course policies. So homework assignments. So I do accept late homeworks, just because I know things happen during the semester, and sometimes it's hard to stay on top of all the deadlines. But if you miss the deadline for the homework, then I do have to dock points. So each day that the homework assignment is late, I do dock 10% off of the okay. And you can turn in homeworks up to a week after it's due. And so if for some reason the Canvas site is not working, you can also scan your homework and email it to me. All right, regrades. And so this is mostly relevant for the midterm exam and the midterm project. That's for the homework assignments. I'm just going to look at them for completion. But I do regrades. Okay, so I'm not, I make mistakes. I'm not perfect. I'm just like everyone else. And so if I made a mistake, either adding up your points, or if you think you deserve more points on a certain part, I'm always happy to look at it again. But I do ask that you you do ask me a week after I give it back, okay? Because, maybe not so much for the ANSYS activity, especially because there's going to be so many of you in the class. I'm not going to really leave a lot of comments on your ANSYS activities, but for your midterm exam, on your midterm project, I am going to give you comments and feedback on this. Okay? And so I want you to be reading those comments and feedback in kind of a timely manner, okay? Especially for the midterm project, because the midterm project is almost like a baby version of the final, right? And so the midterm project is kind of your first chance to do kind of a full finite element, analysis and report, okay? And so, I want to give you feedback on that so you can implement that feedback on the final. So I want you guys to be reading those comments kind of in a timely manner, right? If you don't read those comments until the end of the semester, then it's not really as helpful. Okay. It's like when your mom gives you advice, on things that you should have done when you were 12, and it's like, yeah, thanks, mom. I'm 32 freaking years old now. It's not helpful. And so, you want to get feedback when it's time. So, to kind of encourage this, I have this kind of week deadline where, say I return your midterms on a Tuesday, right? You have until the following Tuesday to look at it, read my comments, and then ask me for a read. Past that Tuesday, I'm usually not going to look at it unless it's an egregious error. Okay, emails. And so if you email me for this class, please include EGME 410 in the subject line. That way it's easier for me to kind of organize stuff because, I get a lot of emails. I'm teaching 2 other classes. I do advising on top of all the stupid spam that the school sends you about like all the fundraisers and pastries with the president and stuff like that. So I get a lot of spam. And so if you put EGME 410 in the subject line, it helps me kind of prioritize my emails and kind of, know that I should answer this email first before anything else. So please put that in the subject line. That helps me kind of respond to you sooner. And if you do that, I'm really good, so I'll answer you within a day, if not within 2 days. Okay. Okay. Any questions on this so far? Question in the chat. Question. So do I grade homeworks based on correction or completion? So for this class, I'm going to grade on completion. Question. Yeah.
For the final project, do we do your teamwork or?
Yeah, that's a good question. So, so the final project is actually designed to be individual. But with that said, I know a lot of people here working in groups for the senior design or for the legacy projects. And so, usually if for a group project, I would ask that you analyze not just one part of your project, but multiple different parts. So, in the end, everyone should be doing, there should be one FEA, everyone should be doing at least one FEA simulation. And so I don't want like a group of 4 only doing one simulation, then only one person doing this practice. So if you're going to be a group of 4, I want at least 4 simulations to be part of the project. And so that's how I do groups. But you can do individual work. Yeah, question. Yeah. So the midterm exam is going to be on the background information. So it's going to be all the theoretical computations. And so, kind of the steps that we kind of glossed over a bit earlier today in terms of assembly of the equations and doing the computations. That's what we're going to do on the midterms. So of course, they're going to be very simple problems. They're not going to be kind of the typical problems that you would have on ANSYS. But you should kind of understand what those how those problems work. In terms of preparation, for the midterm exam, I'm going to give you guys a study guide as well. And one thing that people have been asking me for in recent years is to give you a practice midterm. And so I will post the midterm exam from last year so that you can have it for additional practice. Any other questions on course policies or anything that we've done so far?
Cheat sheet?
Yes. Yeah. So for the exam, you'll be allowed a single 8.5 by 11 sheet, both sides, right? Whatever you want. So yeah. So, okay, graduate credit. And so I know there's a handful of you in the class who are grad students. So if you're a grad student, because this is a 400 level course, you are required to do an additional assignment in order to get graduate credit for that. Okay. I haven't decided what the graduate project will be for this semester. I actually don't remember what I did last semester. But I'll definitely let you know about it, once we kind of get there, okay? If you're an undergraduate student, and so if you're an undergraduate student taking this for graduate credit, and so let's say that this is your 5th or your 6th technical elective, please let me know ASAP, because there is a form that we need to sign in order for you to get that done, okay? There might be a handful of you in that position, but please let me know. And if you're not sure what form I'm talking about, just send me an email. I have the form of it. Okay, academic dishonesty. So honestly, for this class, it's a little bit less of a concern, just because I think most people are generally pretty jazzed to be in this class. But this is something that I have to say. Okay. So just like any other class, academic dishonesty will not be tolerated. Okay. And the definition for what constitutes as academic dishonesty is kind of ever growing with the available technology, right? And so it can be something as simple as copying someone's ANSYS activity, or copying someone's solutions for the exam or something like that, or it could be posting the questions for the homeworks online and having someone else do them for you, paying someone else to do an assignment for you. AI is becoming a thing, and so having AI write your report. Okay. All of these count, and you'd be surprised. You would think that AI would do a pretty good job at writing reports. It does not, and so it's very easy, at least for me to tell, when an AI has written a report. I actually had quite a few instances of that in the spring semester, which were not comfortable. So please, don't use those tools. I want to make sure everyone's doing the answers, everyone's writing the reports. That's honestly how you get the full experience. Okay? And I'll say this, and because I've had a lot of discussions with people over the last few months, just because AI is becoming a big thing now, and people were saying like, oh, AI, you'll be able to use AI in your jobs, and so you should use it in the classroom, and I get it. And ultimately, I think AI is going to be part of everyone's jobs in a certain. And so if this were a company, and and I just needed stuff done, like I needed you to do this stuff just for the financial betterment of the company, yeah, I don't mind if you use AI just because I need it done. But I think a classroom is kind of a different kind of situation, because you're not in a classroom just to get stuff done, right? You're in a classroom to learn a skill that that you can apply towards your career. Okay? Because ultimately, the reason a company is going to pay you is so that you're going to have skills, you're going to have knowledge that's beyond what an AI can do, right? Otherwise, they're just going to use an AI to do this, right? And so, in a classroom, that's where you learn how to apply those skills, how to gain that knowledge, how to, spot, bad results, good results. That's what you're in the classroom for, right? And ultimately, if you're using AI, or if you're doing any other kind of, copying, cheating, any of that stuff, it's going to take away from that. Okay? And so that's why we have kind of such strict policies on academic dishonesty. And I'll say this too, that if you're ever at a point in the semester where you feel like you're struggling, you're not really keeping up with the ANSYS activities, feel like you're going to fail the exam, stuff is happening in your life where it's hard to focus on school, I ask that you come to me for help. Okay? My job here is not to judge you. My job is not to kind of think that you're a waste of time. I never think that it's a waste of time. I never think that it's a bother for you to come to me. My job here is to help you to the best of my ability. I want you guys to succeed. I want you guys to learn these skills. I want you guys to learn ANSYS, to be able to put it on your resume, and to really have that, be confident in that you could step into a job after you graduate from here and to just use ANSYS from day one. Okay, that's my goal, and I want you guys to be able to do that. So, if you cheat, if you use AI, if you do any academic dishonesty, at the end of the day, at that point, it's very hard for me to help you. And if I catch you doing that, there's really not much I can do, because we have such strict policies here at the university. If you come to me beforehand, say if you tell me that you're struggling, I promise you I'll do everything that I can to help you. But that's my job. That's what I'm paid here to do. So please come to me. We'll work something out. We'll figure something out. That I give you my promise. Okay. Last thing that we're going to go over in the slide before we jump to the course website is the first homework assignment. And so the first homework assignment is to email me an introduction. Okay. And so especially in this class, I am really interested in seeing, what you guys are wanting to apply FEA to. Okay. So send me an email, just introducing yourself, state your name, your major. Okay. and you'll get full credit just for sending me an email. Okay? So you can write as much or as little as you want. You can write, I think last semester I literally got an email that said, hey, Dickface, give me credit for this assignment. And I gave them full credit because that's what the assignment was. They later followed it up with a much nicer email, but that was kind of their first. But just introduce yourself. I'd like to know kind of where you guys are coming from, what you're interested in learning, that's all that stuff is really nice. Right? And so I have these 4 questions here. You don't have to answer these 4 questions, but if you're kind of struggling with figuring out, what you want to say or what you want to kind of say in your introduction, you can use these as a guide, right? And so you can say, what kind of career you're interested in after graduating, what would you like to learn most about from this class? Do you have any worries or concerns about the class? And just what are your interests and hobbies? So, those are 4 things. You don't have to answer them, but, those are kind of a good kind of start. So the due date for this assignment is this Sunday. And so please send me an email by then. And so if you do it by then I'll give you full credit. And please don't forget to add EGME 410 in the subject. Okay. All right, any questions on this before we jump to the website? Okay, all right, so let's take a look at the course website. Just so I can show you kind of before, just to kind of give you a brief tour. All right, so if you've been my student before, the course website is organized in the exact same way. I worked really hard one summer to make a template, and I'm cashing in on that hard work by using the exact same template. Okay, so don't work smarter, don't work harder, work smarter. Okay, all right, and so this is how the website is organized. So we have the name of the course. We have my name. You can click on it. You can see my little Tinder profile with a picture that's 5 years old, like everyone's real Tinder profile. Okay. We have the time for the class, the location. Okay. We have the description of the course. We have the learning objectives, which we went over. Okay. We went over basically the whole syllabus, but if you want to review different parts, you can click on this as well. So this is the PDF version. So I was telling someone before the class that I used to print these out and staple them and give them to everyone, but I thought, let's save some trees, and so let's not do that anymore. Okay. So here are the Zoom links, and so if you want to attend the lectures virtually, click on the link here, and here are all the other links for the office hours. Okay. Oh, let me say this too. So we're going to be doing a lot of ANSYS activities in this class, and so that's going to involve using ANSYS interactively in the class. Okay. You are definitely welcome to attend those ANSYS activities online on Zoom, but it's a lot more difficult for me to help you when you're on Zoom. And generally speaking, when we're doing these activities and I'm kind of going around and helping people, it draws my attention a lot more to have someone physically in the classroom, kind of like with a semi-upset expression on their face, raising their hand. I'm much more inclined to go help that person rather than coming to Zoom. So for the lectures where we're going over the theory, I would say you can do either one. But for the ANSYS activities, I do highly recommend that you come in person, just because it's a lot easier to make. Okay. Question, yeah.
ANSYS require student version or full version?
Yeah, so everything that we're going to do in this class, you can do in the student version. So the versions of ANSYS that you have here in the lab, they're a little bit nicer than the student versions. They have a little bit extra features, and you can do a little bit more. But everything you can do in the student version. Yeah.
What's the difference between the two?
So the main difference is the element count. And so one thing that we'll learn, probably not on Thursday, but and for the second activity, is that the accuracy of your simulation, the reliability, depends heavily on how many elements are in your mesh. And so for the student version, I believe the limit for that is 64,000 elements, which it sounds like a lot, but it's really like almost nothing. And so it's fine for an educational tool, which is kind of what it's designed for. But if you want to use it for something practical, then it's very difficult to get good results from that. I think in here on these computers, I think the limit is at least double. So I think you can have up to 120,000.
Okay. So on the projects, do you want us to try to use these computers?
You can still do the project on the student ones, but you'll get better results.
So if we start like the project on these and then try to I don't know, if you can email it to yourself, you won't necessarily be able to open it with the student version.
you'll be able to open it, you might have to course in the mesh.
Okay.
Yeah, so you'll see on Thursday that you can change the number of elements in the mesh. And so, you might start a project here, but if you take it home, you may have to course in the mesh or reduce the number of elements just so it'll run. Yeah. Any other questions on this? Okay. All right, and so here is the link for the Discord server. And so if you're interested in that, you can click on that. But the main thing I want to show you here is the course outline. And so at the bottom of the homepage, you'll see here that I have kind of a week by week breakdown in terms of what I plan to cover in each of those things. Okay, and so if you click on week 1, you can see here we come to a different page here where I have the title of the week. I have a little blurb that kind of describes what we're going to do for the week. Okay, I have the learning objectives for the week. Because I'm streaming all the lectures on Zoom, all the lectures are going to be recorded. And so once I record the lecture, I do post them on YouTube. And so you'll be able to click the links here to view those recordings. Okay. You can click on the assignments here. And so we have 2 assignments this week. We have the homework 0, and we have answer activity 1 is already up. And so if you want to take a sneak peek at it, you can see it here. Okay, but we'll go over this together on Thursday. And any lecture notes for the week are going to be posted here as well. Okay. So I organize the course kind of chronologically, and so it kind of helps to kind of if you kind of miss a week or if you need to go back to a certain week, it kind of helps to know kind of when certain things happen in the course. Okay. And so you can kind of see from the outline here, when certain activities are. I think generally speaking, people like to view the recordings for the answers activities just so you can see kind of my step-by-step kind of process and answers. And so, you can use that to kind of organize when you should, which recording that you should see. Okay. All right, but the homepage, you'll probably spend most of your time here as well as the weekly pages. All right. Any questions on that so far? Okay. All right. Next tab here is we have announcements, and so you probably won't come here too much because again all the announcements will be sent to you via email, and so you'll be able to view them that way. But if you accidentally delete the email, you think that Professor Tran, that's spam, and so you can view the announcements here as well. Okay. If you click on the assignments tab, you can see all the assignments that are there. Okay. And so if you click on the assignments, you'll be able to view the specifications. If the activity requires a CAD file, the CAD file will be posted there as well. Grades, and so you'll be able to view your grades here as well. Okay, so once I've graded something, you'll be able to see them here. People, and so if you're curious, see who's in the class, you can see here. I don't know why this is a tab. I'll probably disable this, but this is kind of my background thing. But you can view all the different pages if you want. So there should only be 2. So there should be home page and week 1. And then finally, this last tab right here is the files tab. And so if you're kind of on top of things on a week by week basis, you probably won't come here all that much. But if you're looking for certain files, this is kind of where I post it. So all the answers activities, all the lecture notes, all of the study guides, practice exams, solutions, all of them will be posted here. And so if you're looking for a very specific file, then you can find them here as well. Okay. Okay, all right, and so that is the tour of the website. And so are there any final questions before we wrap it up for today? Yeah.
It's just considered like the most powerful FBA software.
It has a lot of features. I wouldn't say it's the most powerful. It's definitely the most it's the most versatile, and so you can do a lot of different things in ANSYS. But I would say if you're interested in a very specific thing, like a very specific type of structural analysis, there's probably better options out there. Specifically, like a lot of research software. But as kind of like a first software to use if you haven't used it before, or if you're just doing an analysis for the first time, ANSYS is probably one of the best. Any other questions? All right, so that's all I had planned for today. So I'll stick around here if you have any other questions. And so Thursday, when we come back, we'll be using answers. It's gonna be a hectic day, but it's gonna be a lot of fun. So thank you guys for coming today. I hope you guys enjoy the rest of your day. And I'll see you all on Thursday. How are you? Okay, yeah, and then, yeah, thanks for letting me know. Somebody have you take the picture in my office. Yeah, just for the first time. He's in the way, looks like a. Okay. Yeah. So you can in your introduction email, you can just. Yeah. 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 It does. Okay. Yeah. Yeah, I mean, if it's gonna be 51 in the class, that's very hard for me. It's very hard for me to say like, F this person in particular. So if it's 51, I'll do 51. But if it's like 52, 53, then that's but stick around until Friday and then you can, it's just CFT in particular, like we said, the accuracy depends a lot on the elements. CFD is a lot more simple. So you can really, for the student version, you can only do very simple.
It's like just stick around. It's like if it's 51, fine. Like if more get in, then like can't be like
yeah,
51. Yeah. If you're within 15, you're fine.
Open foam is definitely better.
Yeah.
There's no limitation on the elements. And open foam was designed kind of from the get-go to be CFD software. With Ansys, they developed the software for solving against first, and they're like, we can sell more software if we add fluids, so they kind of duct tape things on top of it. I mean, it's good, it's still good. It's just open foam it's going to be a lot better. Yeah.
How many people?
There's 35 in the class.
Okay.
And so if you're 10. So the only thing, so I thought the capacity of this room was like 60 something.
Yeah.
But then someone came up to me and said that the capacity only 40, which doesn't sound right. Because I've had FBA courses with 53. It was fun. So, we didn't examine this class, but it was okay too. So it's gonna be, but I'm gonna double check with the department to make sure I can have it. Yeah.
That's my one.
Okay, yeah. Yeah, so send me an email. So in your introduction email, just mention that you're not on the campus site, and then I can add you. Yep. Yeah.
Same thing.
Yeah.
However, I'm under 13, so I know that's like 2.
So there's 35 people in the class right now. So if you're 13, then you'd be the 40. So I planned for 50. I mean there should be more than 50 seats in this room. And so it should be fun. So yeah, just stick around. I'll double check with the department to make sure we have enough people in this class. Because I thought the capacity in this room was like 60 something. I've had like 50 people, and I've had like stragglers in the back. Not to okay. Yeah. Yeah. Oh no, was I already have. Oh, it's just yeah. I'm still gonna be there. Okay, so I am with the full shadow here. Okay, yeah, just stick around and then yeah, by Thursday I'll email the department tomorrow, and by Thursday I'll tell you the capacity of the room and how much. Yeah. Okay. Yeah. So I'll say this. So if you're on the wait list at the end of the day, before the class day, you have a pretty good chance of getting in. So I don't want to add the class afterwards. So but I know you were on the wait list before, so.
But in terms of like, I need to get access to Canvas website, I just have to send you.
Yeah, so in your introductory email, just said, I'm not on the Canvas site yet, can you add me? And I'll add you. Yeah.
Hi.
I
just want to say, I'm Constance.
Yeah.
I didn't know it's a class yesterday for a virtual, but it's posted online.
Yeah, it's supposed to.
And then I saw the honey sort of summit.
Yes.
Would be alright if I
Oh, yeah, just put both class numbers in the subject line. Yeah. Yeah. Hey. Yeah. Yeah.
322 levels.
All the activities are gonna be limited.
It's for me, it's just more of the.
I see.
Who?
Big thing, I think.
So I mean, all the activities are the same, so I mean, no, I mean, they're not exactly the same, but they're very, very similar. So you'll be able to, use a lot of kind of what you did before, at least the same answers results. The theory stuff is probably, did you ever take 541? Okay, so the theory stuff will be new, but that's probably only about a third of the course. And so, probably in terms of workload, because you've done a lot of it already, it's probably not gonna be that much. But it's gonna be boring and firstly for me, it kind of feels like it would be kind of a waste of like a class slot, because you only take a limited number of courses when you're president. So in general, you want to take all different topics.
I see, because I was trying to take 3 classes as opposed to, so I usually take 2.
Yeah.
So I wanted to take, because I only need 1 semester, 3 classes.
I see.
This is the first semester, like for 5 minutes.
I see.
Wasn't sure, like, I pushed 3 classes to the last semester.
Mhm.
And do all of the front work and projects.
Mhm.
Semester.
Right, yeah.
So that's my double failing right now. So
Gotcha.
I want to take the 3 classes now. This is literally the whole.
Gotcha.
In terms of it like, helping me out in terms of that. So I'm not really sure.
I see. So there's no other tech lectures that are you free before this class? So before this class, I'm teaching 454, which is optimization. I think you'll find that one a lot more. Yeah, there's more spots open. Too, so
Also Tuesday.
Also Tuesday, Thursday, but from 4 to 5:30. Same with here.
Okay.
Yeah, I think I would recommend that over taking this class just because this class can help. It'll be easy, but I think when you look back on it, probably in a year or so, like, oh, that's kind of a waste. Yeah.
It's just for me now it's 3 and 2 and then
Gotcha.
I want to like, because I heard a lot of people need semester.
Yeah. Things get more hectic.
Yeah, so I feel like if I take 2 classes right now, do all the department work this semester and then it's just down.
Yeah.
It's just. But at the same time, if 3 classes is too much.
Yeah. Honestly, probably if you start a project now, most projects take at least a year, so you'll probably be finishing up in the summer. Unless you really, hustle with it, you get a lot of data really early on. Typically, you spend the fall semester. So if you start in the fall, you spend the fall semester kind of figuring out your project, learning the tools, kind of, changing those stuff. Spring semester is kind of when you get a lot of the data. So that's when you actually apply it and actually generate stuff. And then summer, and so the end of spring and kind of summer is kind of when you start to actually fully put together, you write the report, you form your committee, you defend it, and things like that. So yeah. So you'll definitely have more time over the summer. But that's for most, at least for my students, they take at least a year, so they end up finishing over this.
Would you recommend taking 3 classes now?
Honestly, I would do it just based on your interests. So I would see which classes are available. And so if there is another tech elective that you that is really interesting to you, that you want to take, I would say go for the 3 no. But if there's really nothing, and if you are just taking it just for the units, I would kind of wait and see what's go. Yeah.
Share.
Mhm.
So